All right, so hello everyone. Welcome to the Secure Developer, an inclusive community that educates and enables developers in application security. Coming up, we'll be joined by Scott Helme talking about deploying HTTPS the quick and easy way, so taking us from zero to hero, basically. But before we do that, I want to quickly introduce myself. My name is Untitled. I'm a developer advocate at Snyk. We'd love to hear your feedback throughout this session to improve. You can find us on Twitter on hashtag #TheSecureDev or on our Slack group. So the Slack group is actually the best place to interact with the speakers and with the fellow community members. If you haven't already signed up, you're welcome to do that through thesecuredeveloper.com, the website, and also by joining our hashtag live sessions on the Slack community, and we'll be able to facilitate your questions to Scott during that session. So if you're listening after the live session, it's also possible to just jump on the Slack and we'll get that sorted out. With any questions that you have, once the session is over, you'll have an actual link on the website that you can share with friends for the video. And that's it. So the Secure Developer is brought to you by Snyk. We aim to be a vendor-neutral space to share knowledge and best practices related to software security. So with that said, and without further ado, I'm going to hand it over to Scott Helme. So Scott, welcome to the Secure Developer. How are you doing?
Hello, thank you for having me.
Awesome. Glad we have you here.
Do you want me to run a bit of an intro? Have you got any
yeah, go
kind
for
of intro
it.
piece, or should we just dive straight into the tech?
Go with an intro.
I'll sneak a little bit of an intro in there. So for the people that don't know me, my name is Scott. Thank you very much for joining us. I will be paying close attention to the slides because I've got a really heavy practical session now. So whilst we're kind of going through this intro, if you do want to sign up there to ask questions, that would be really good. Quick background on me. I go by the job title security researcher, so you can see my blog is here. I'm really active on Twitter as well, so if you do want to catch me with any questions afterwards, shoot me a tweet or a DM, they're open. And if you have heard of me before, perhaps it's either from one of my two projects. You may have come across Security Headers. We're actually going to talk about this today and use this, or it may have been my other project, Report URI. So we won't have a chance to talk about this one today, but those are the two things that chew up most of my time right now. But today, I'm going to be talking about something that I'm super passionate about, which is encryption and TLS. And as we said in the intro there, how to do it the quick and easy way, because there's a lot of kind of old habits around TLS and kind of misunderstandings from years gone by. So hopefully today we're going to look at just how easy it can be. So I think that covers us for everything. I've got my Slack open here, as I say. Laran, are we good to kick off? I'm good to go?
Yeah, you are my HTTPS headers hero, so we're definitely good to go.
So just a kind of a brief introduction, first of all, to the practical kind of side of things that we're going to be looking at today. Everything that I'm doing is live. So I did my prayers to the demo gods this morning, and hopefully they will look upon me with favor. But you should be able to see this website online right now, which is what I'm going to be using throughout the course of this demo here, which is demo.clued.net. So you can hopefully be able to open that up in your browsers now. You should be able to see a super basic HTML page. There's nothing particularly fancy going on. But as you'll see in the top left of my browser here, I have this little not secure warning. That's because we're accessing the page over HTTP, and this has become a much more kind of prominent feature in websites, and certainly in like mainstream browsers more recently, where in days gone by, we used to talk about green padlocks and look for the green thing in the address bar and all this kind of green positive stuff. And it didn't really serve us very well. Many users would often misinterpret what the green meant, and they would think that it somehow meant the website was safe or trustworthy. Like, I can give this website my credit card because I can trust them because they have the green thing, and that's not what it meant at all. It just means whether or not the connection is encrypted. So as you can see on this site here, the connection is not encrypted. We're on HTTP, of course, and we have this not secure warning in the top left. Now, I am actually running a slightly ahead of time version of Chrome. If you are using Chrome, you'll probably see this as a gray indicator as opposed to the red indicator that I have here. But if we fast forward just a little bit of time in Chrome into the future, this is what everybody will see by standard by default, this red not secure warning. And again, it doesn't mean that the site is bad or that it's going to do anything bad. It's what we call the connection security indicator. If you expand it out, it says your connection to the site is not secure. So it doesn't mean that the site is bad in any way, just like the green one didn't mean the site was good in any way. It's just, do we have a safe connection to the site? So one of the kind of the first parts of this session now that I want to talk through is how to fix this problem. How do we get rid of this red not secure warning, or the gray one if you're on current stable? And how do we get it to a secure connection? Now I'm just going to jump back to my site just for the comparison here. So again, this is what a secure connection looks like. This is my blog. I run this, and of course I have a certificate installed. Now, not even that many, kind of months or a year or so ago, you might have expected to see a nice green indicator up here. It would have had a green padlock, certainly, and it usually had the word secure in there as well. So as we are kind of peeling back these green indicators, we've taken away the green, we've taken away the secure, we're taking away the positive indicators. These negative indicators are being introduced. So actually what we're trying to do is, it's basically like flip the model. So instead of having like green positive things, we're going to take all those away and just introduce these bad red ones. Now, we still need to make these go away. And this is what we're going to try and do. Now, just to prove that nothing is working right now, if you try and go to this website on HTTPS, and again, this is all live, you can follow along and try this, you'll see that it's all just completely broken. And we actually get this big, huge warning because it's not even configured properly. So this is how, on my TLS training course, I do a 2-day course on this. So we're going to chop this down into an hour. Excuse the corners that we cut. This is actually the starting point. Basically, nothing works. Everything is broken. And we're going to do this now, the quick and the easy way. So in order to kind of check our progress, we need some kind of metric. At some point, this will all be properly configured and the browser will load the page and the warning will go away. But there's actually kind of like a sliding scale in the middle there. And in order to give us visibility of that, as we go, I'm going to be using this really popular tool called Ssl Labs that I use quite frequently. Now, Ssl Labs is free. Everyone can go here now and use this. It's not like a paid service or anything like that. You can click on the test your server option here. And what you can do is you can type in your website. I'm going to type in mine, but you can type in any website you like, and you can run a quick scan. Now, it takes about a minute. I'm going to leave this running here. And what Ssl Labs will do is it's analyzing the TLS, the encryption configuration of the site. And here you can see we've just got an absolute failure because, like I said, it's totally broken. So what we're going to do is we go through is you can rescan this and we'll be able to see the progress of each step that I'm taking, and then eventually things will start working and loading in the browser as well. But this is a really common place that I come. Sometimes I just like to analyze a site, see if they have good configuration or not. If you have a problem and you don't understand it, this is super easy to get some potential quick and easy feedback on how to fix that as well. So I'm going to leave this open because we're going to be rescanning this as we go through. Now, the next thing is the server itself. So I'm SSH onto this box. I'm running Ubuntu. I think we're on 1804 LTS if you're interested here. I don't want this to be a tutorial about how to use Linux. So what I'm going to do is try and not focus on any of the specifics of using a Linux host for this, but actually just the process of setting up TLS that I'm going through. So I'm going to try and abstract like the platform away as much as possible and talk about just the relative encryption things. Now, what I'm going to do is we're going to start the process. If you want HTTPS on your website, there are an absolute minimum number of steps that you kind of have to go through. And we're going to look at the basic kind of steps in here. Now, the first thing is that you need a key. So we're going to have to generate our keys that we're going to actually use to set up HTTPS on our website. Now, I'm going to be, as I said, depending on your platform, this will change, but I'm just going to generate the key that I need here. So I'm going to create the output server.key and 2048-bit key. So I'm using the OpenSSL genRSA command to create an RSA key pair. And it's a 2048-bit key, which you can see at the end. That's the current minimum size that we must use. So as security standards kind of march onwards, the minimum key size gets increased. So we always have to make sure that we're meeting that minimum guideline. So I've generated a 2048-bit RSA key pair. And if we have a look in this directory, we can see that server.key is indeed there and been created. So this is now it's actually a key pair. So there are two keys in there, our public key and private key. But most of the time you will commonly hear people just talk about the private key because that's the only part that we actually care about. That's the secret bit. So my actual key pair is in there. but I only care about the private key. So when I keep referring to the private key, the public one is also in there. I just don't care about that part because it's not too important. So now we've got our key. The second step of this process is to generate something that we call a certificate signing request, or a CSR. Now, this is kind of the formal document that you send to a certificate authority to get them to issue you a certificate. It contains all of the details about me, about my website, what domain names I own, what domain names that I want the certificate to cover. So this is like essentially it's the application form for a certificate. So we need to start the process of creating that application form. Now, I'm just going to open up a file in an editor here. It's just called I'll just call it like my.conf, my.cnf. And I've actually got the config here because I'm going to type this whole thing out. So I'm just going to paste this in and talk through it here. So this is the basic for the configuration. And there's only actually really kind of two important parts that we're going to look at for just now. And the first one of them is what we call the common name, which you can see defined here. And it contains the name of the website that I just showed you, which is demo.clued.net. Now, historically, the common name field in certificates is actually only allowed to contain one name. So historically, one certificate could only contain one name. But of course, I have loads of subdomains. I'm sure you have loads of subdomains. And companies now might have, company.com, .net, .co.uk. You might even have multiple domains. So we have this field down here called the subject's alternative name. And the SAN, as we commonly refer to this, allows you to have multiple names valid inside a certificate. So you can see that I actually have two declared here, which is www.demo.clued.net and demo.clued.net, because they are actually indeed, demo.clued.net is just there. And if I go to www. They actually both resolve to the same host. So I want the certificate to work for both of those names, which is why they have to be declared here in the configuration. So those are the only couple of things that we're going to look at for now. As you can see, this is super small, basic configuration file. Just going to save that out, get rid of that one with the typo in. We don't need that. Where was it? Let's have a look.
But this is
I didn't create it. That's okay.
So this is a configuration file for the certificate itself, right?
Yeah, so this is what I'm going to use to generate the CSR now. What I'll actually do, I'll just dump that into the Slack. So sometimes I know it's a bit small on the webinar, so I've just pasted the configuration into the Slack as well for anyone watching. But this is the configuration that I'm going to use to generate the CSR now. So the CSR, the certificate signing request, that's like the application form. So OpenSSL request, I need to create a new one. Config, so I'm going to pass in the config now, which is what I've just generated. The key I already generated earlier is called server.key. So it's like, here's my key, here's my configuration, and I would like you to put that into a CSR file here. So again, what I'll actually do, I'll keep copying and pasting these commands over just in case anyone's struggling to see on the webinar. So I'm creating a new request, a new certificate request. I've passed in the configuration, which contains the domain names, the key, which we've already generated, and I've asked it to output that into server.csr. So if we look now, indeed, we have our certificate signing request. So that, that certificate signing request is now actually ready to go to a certificate authority. Now, people may have heard of them or dealt with them as part of their job. So you've got like Komodo, Sectigo, DigiCert. There's like these companies that sell certificates. So you would take this file, you would send it to one of those organizations, typically pay, like there's a small cost for a certificate, and you would get your certificate back. But we're actually not going to use any of those organizations today. I'm going to use an organization called Let's Encrypt. Now, Let's Encrypt are a certificate authority, just like the other ones that I mentioned. So there's no, there's no real technical difference between them. The main difference, and the reason that I'm going to demo with them right now, is this one just here. Let's Encrypt don't charge for certificates. So Let's Encrypt, you can use their organization. They will issue certificates, and you don't have to put a credit card into the process, to get the certificate out of the other side. So if you've not heard of this organization, you should check them out. They're a really good organization run by a great group of people. And of course, they're enabling people to use encryption that couldn't previously use it. Because if you think, I want HTTPS on my website, I want privacy, security, and all of those great things, there's actually a step where you have to get a credit card out. And that meant that there was like a direct cost barrier. And that actually stopped a lot of people getting certificates because they literally couldn't pass the cost barrier. So Let's Encrypt removed that cost barrier and allowed many more people to to progress down the road of deploying encryption. So they're the organization that I'm going to use now to show you just how kind of easy this can be. Now, in order to do this, when we go to Let's Encrypt, we need to use some kind of tool to interact with their API. So what I'm going to do is go through the setup steps now in order to use that tool. So first of all, I'm just creating this directory in my www folder here, which is already there actually. And this is where we're going to host a challenge file from. And I'll talk about that in just a moment because we need to prove control of one of our domains. Can we make the terminal bigger? Yeah, I thought that might be the case. Sorry, hang on. I've just got a question come through to see if I can make this bigger. Let me see.
It would be just zoom with Command Plus or something.
Yeah, I've only got, I use putty usually, but I can't. Let me just see here. I've got the settings open now. I'll make it bigger for the webinar. Yeah, right, font, where is it? Window, appearance. Yeah, I'll just see if I can make this bigger. For a couple of people mentioned it now, so it's worth doing. What if I go up to like 16? Let's try that. Oh, wow, that's quite big. There we go. Hopefully that's okay. It was a bigger step than I thought. Well, hopefully that makes it a little bit better for the people asking there now. I want to make sure everyone can see this. So I'll pick back up again. What we have to do when we go through the process of applying for the certificate, there's actually a couple of steps. The first one is to send them the CSR. So you say, here is my application. Now, inside my application, as we saw, I'm asking for a certificate for this domain here, for demo.clued.net, and also one of the subdomains. Now, of course, the CA actually needs to check that I own that domain. You know, I can't type paypal.com into this and expect to get a certificate for PayPal. So one of the things that the CA is going to do is check that I own it. And they ask me to do that by hosting a challenge file. So during the application process, the CA will give me this challenge file and say, okay, put this like small file on a random path. And if you can put that file on the path, we accept that you control this domain. So as part of this process, that is one of the things that's going to be happening. Now, the tool that I'm going to use to do that, and I will just go in here now. Oops, don't want that one. We want GitHub, and I'm going to search for Acme Tiny. This is the tool that I'm going to be using. Now, Acme is a protocol that you can communicate with CAs. Acme Tiny is just an implementation. It's a super minuscule one. It's actually, last time I checked, it was about 200 and something lines. Oops, 200 and something lines of Python. Let's have a look. So yeah, I mean, this is 198 lines for this tool, and this is what I'm actually going to be using to communicate with the API. So just going to grab a copy of this, because this is what I'm going to be using. Oops, if I could type and spell, that'd be fantastic. There we go. So that's the tool that I'm going to be using to speak to the Let's Encrypt API. And now I'm going to make the directory. So var /HTML and then .well. Now -challenge. So when you communicate with an API using this protocol, there is a fixed directory that you have to put the challenge file in. Now var /HTML is my web root. And the fixed directory that you have to put the challenge file in is always .well-known and then /acme challenge. So I just made that directory there because that's where we're going to have to put the challenge. Now, we're all ready to roll now. We've got the CSR generated. That's basically the application for a certificate. I've got my web server running here. I've downloaded Acme Tiny, which is what I'm going to use in order to communicate with the API. And now it's just a case of using Acme Tiny to go to Let's Encrypt. So actually there's one more thing, and this is why I should read my notes. There's one more thing that we need to do before we get started, and it's to create a key to use with Let's Encrypt, and I'll explain what that is now. So the Let's Encrypt API doesn't issue like API tokens. You don't have the username and password credentials. They use a key-based authentication. So I've just generated this file here called let's encrypt.key, and that's what I'm going to use to register my account with the API. And then if I ever re-interact with the API on an ongoing basis, this key is what I will use to authenticate with it. So that's basically my username and password for the Let's Encrypt API. You could probably consider it to be just your credentials. So I'm going to ask Acme Tiny to go get me a certificate. We're literally going to go get a certificate right now. So account key, Let's Encrypt key. The CSR is the one that we created earlier. The Acme directory will be in the one we just created. So it's www.html.wellknown Acme challenge. And I'm going to put that into a file. So again, just super quick recap. I'm asking Acme Tiny to go to Let's Encrypt using my key, passing the CSR to them. And when they ask us to write the challenge, it's going to write it into that directory that I just created. And that's how we're going to prove that we own the domain. Now, I'm going to run this. I'll try and talk through it. Some stuff's going to zip by, but we'll cover everything. So you can see here, it's parsed my account key in CSR. It's seen that I'm asking for a certificate for these two domains in particular. It's looking at the Let's Encrypt API now to see how it's supposed to interact with it. It's registering my account. Of course, this is a brand new setup, so I have to actually create an account. Once it's done that, the next step in the process is to create a new order. So an order represents an application for a certificate, basically. My order has been created. It will now attempt to fulfill that order. And to clarify as well, the Acme protocol does have support for payment. It's just that Let's Encrypt don't use it. So there could be a payment process in here as well. Now they're verifying that I actually control these domains that I've claimed. So what it will do is it's going to take the challenge, write it into the directory, and then Let's Encrypt are going to connect to my website to see if they can download the challenge file. And if they can, that proves that I must be in control of the website because I put the challenge in the correct location. So the script will write the file, tell them that it's ready. Let's Encrypt will then connect back and check. And as you can see now, it's just come back and said that the ownership has been verified because I successfully put the file into that correct location. It'll now go through the step for the next one. And again, if you have multiple domains, it will go through this process and obviously check that you control each individual one. Once Let's Encrypt have verified that, they'll go through the process of issuing the certificate. So any second now, that should hopefully complete if everything's working as intended. And then they will actually say, we're going to send a certificate signed, and then it will present it back to me. So there we go. Pre-control of the last one. Let's Encrypt now issuing the certificate. This is all happening in real time. So I am hoping that this all works as intended. They are currently issuing and signing the certificate right now. And in just a second, I should get that certificate back from them. So that's this is like just the first step. Don't get excited yet, we're not finished. But this is the first steps of the process, which is to actually, to get a real life certificate, if you will. So their API must be busy right now. As a free CA, you can imagine like how, say again, sorry?
But I said that that's a pretty handy utility, the Acme Tiny script, to just go through all of that for you and get it done.
And there are others as well. Just to clarify, Let's Encrypt have like a more official client called Certbot, and I'll put these up on the screen just so. Let's Encrypt Certbot, run by the EFF. So this is kind of their more official one. It's very handy. It's got loads of super good features. I just like using Acme Tiny because it doesn't help me as much, and I like to get more hands-on. But if you want a tool that helps you more, Certbot is fantastic. The other one that I use is acme.sh as well. So if anyone's looking to try different clients with different features, I would certainly recommend those three. And just quickly, as we can see on the process, the certificate was signed and done. I'm just going to check the questions here. Can we have one certificate per one domain having multiple subdomains? Yes, is the answer to that one. So if you want, you can see here that I'm on the site demo.clued.net and I have the www.subdomain. You can have as many different subdomains in there as you want within reason. There is a limit, but like generally speaking, you can comfortably go to 100. So that's kind of okay in that regard. But if I wanted to, I could do clued.net, clued.com, clued.co.uk, like whatever I needed. You could also mix and match those as well. So as we can see here, certificate signed. So whilst I was kind of talking, the tool was doing that whole process for me, communicating with the API, and has in fact now got me a certificate issued from a CA. So as you can see, I asked the output to go into a file called server-le.certs, and we can see it has created that. And if we take a look inside there, so let's have a look, you can see we have, I've just asked it to output the file. We can see here is the first certificate. Now, the reason there's two in here, and I'll come on to this point a little later, but you might see that there's two. The top one is my certificate that was issued to me, and then a little bit further down the file is a second one. That's something that we call the intermediate certificate. And one of the good things about using Let's Encrypt like this is they've automatically put that there for me. Sometimes in other processes, you would have to manually go and fetch that and add these to the file together, but this is all taken care of for us. So this is just the first part of the process. We've generated our key, generated our CSR, our certificate signing request, and we've gone to Let's Encrypt and got a certificate. But this, like I say, is just the start of the process. Now, I'm going to take a look at my server configuration. I'm running a really basic Nginx setup here. So the server is listening here on port 80 for any requests, and the server is listening here on port 443 for any requests. And as we saw, obviously, the port 443 configuration is totally broken. So we're actually going to start focusing on this section now and looking at how to use that certificate properly. So the first thing that I'm going to do is I'm just going to come down here and I'm going to reconfigure it to use the certificate that I just got. So there's server-le.cert, which is the certificate Let's Encrypt just gave us. And I generated a file called server.key. So it's the only thing I'm going to change. I'm going to quit and save those changes. And I'm just going to restart the service now in order to actually reflect those changes. So hopefully if we go back to the browser, you can see here we're on HTTP. I'm going to go back to HTTPS. And you can see already that now we're using a genuine certificate from Let's Encrypt. It's removed that error message. And if we in fact inspect it up here, we can see here is the certificate for demo.clued.net issued by Let's Encrypt. And of course, it was valid from just now, the 12th of September. Now, that looks like we fixed everything. And this is kind of where some of the problem starts is that TLS configurations are a little bit more nuanced than just that. And what I'm actually going to do is I'm going to go back to SSL Labs and I'm just going to rerun this scan. Now, yes, everything is currently working, but it's not properly configured. We can do a lot better here. I'm going to let this scan run through. It only takes about a minute. And you'll see the kind of feedback that you get from SSL Labs, and you'll also see the kind of problems that we have with our configuration here. So if anyone, as I demoed this earlier, if anyone's kind of gone and scanned a few different websites, what you'll see, and what we'll see in a moment, is you can get anything from an A+ grade all the way down to an F grade from SSL Labs, depending on, of course, the strength of your configuration. Now, because we're running like a default out-of-the-box setup, we're going to have a pretty bad score here on SSL Labs, and we're going to work through the steps of how to take that to a strong configuration. So I'm going to let that keep running, and I'm going to show you how we're going to move through to a stronger configuration. Now, I can write a lot of this stuff from memory, like all of the, we're going to talk about protocols and Cipher suites and all of these weird things that, to be honest, like most normal people shouldn't remember off the top of their head. So what I use is the Mozilla SSL config generator. So if you search for the Mozilla SSL config generator, this is the thing that I commonly refer people to. April King maintains this absolutely just stellar tool, and I refer to it all of the time because there's so many different aspects of the configuration that we're about to go through. You shouldn't have to remember all of these configurations. So I'll just zoom in a little bit again for people on the webinar. You can see here, you can pick your server platform if you were to be configuring different platforms. Mine's already selected. I just happen to be using Nginx. And the intermediate configuration is selected by default. This is a really good starting point. So I'm actually just going to leave these two settings here. Maybe the only thing that you would need to do is change your platform here. And then if we look down below, it actually has the example configuration that you would need to use. Now, I don't advocate copying and pasting things just, from the internet. This should be read and understood so you know that what all of these things do. And we're actually going to go through this part by part now in order to understand the changes that we're making. So if I flick back over to the SSL Labs test, it should be just about done. And what we'll probably see now is a really bad score kind of like pop up on the screen. So I'm just going to wait a second for that to complete. And then we can start talking through the problems that this report shows. So there we go. It's like watching a kettle, isn't it? I don't know if that saying is universally applicable, but it's the watch kettle problem right now. So here we go. We've got 99%. There we go. So you can see this is a terrible grade. Now, the really interesting thing here is that if I go to the website in the browser, it's loading okay, right? I can refresh the page. There's no warnings. We've got a padlock in the address bar. But actually, the configuration is dreadful. It works, which is why the page loads, but the configuration itself is dreadful.
And I think the concern is basically that most people probably stop after this, right? Like they maybe use some default configs, certificate, and that's it.
And this is kind of the problem, right? Like, it's like, okay, I've done this thing and my website works. And you can forgive people for not realizing that there's actually like this whole other bunch of stuff that's supposed to come afterwards. Mm-hmm. Now, the only time that normally catches people out is, of course, as we've seen now, my site is working, but it's got a dreadful grade. So there's obviously a spectrum of configuration from bad to good. Now, the only reason this usually catches people out is when the browser shifts that bottom end up and a couple of websites will fall off and suddenly stop working. That's usually when people realize that actually there's this little bit more that we have to go do. Yeah. Now, pretty much most people just want this summary here from SSL Labs. And I have to say, most of the time when I come here, this is just the thing that I'm looking at. Is everything good? Are we on like an A or a B and everything's green, or is it red and we've got all of these orange things down here? So we're going to start working through some of the problems. If you are interested in technical data, there's just a whole heap of stuff further down the page on SSL Labs. And we're going to start working through the really key ones now. So the first one that we're going to take a look at, I'm going to go back into my server configuration. The first one that we've got to address is this protocol line just here. Now, there's loads of different protocols, versions that you can use for HTTPS on your website. And you can actually see we have two really old ones here. Going literally way back into the 1990s, we had SSL version 2 and version 3. These things are super old and they're just not even acceptable for use anymore. So we're actually just going to take these out. So SSL version 2, version 3, are completely kaput and we shouldn't use them. Now, we're at a bit of a crossroads after that right now because technically TLS version 1 or 1.0 as you'll commonly see it referred to is actually okay. We're right at the end of the kind of the lifespan right now. So if you want to, you can leave TLS version 1 and above. If you're a little bit stricter on the security, you might delete them out and say, no, actually, we're just going to do TLS version 1.2 and nothing. And that would require a slightly more modern client in order to be able to connect with these newer versions. So I'm actually going to leave those just as they are because for the purposes of this demo, I'm happy with TLS version 1 and above. So I'm just going to save those changes. I'm going to restart my server. And what I'll do in the background is I'll kick this scan off and let it go again, because that will actually improve our score slightly. Now,
generally speaking, leaving those old protocols means maybe we would support some older clients like IE5, 6 or something like that. But also, if we use something very modern, might mean that we will be breaking some compatibility or maybe like API scrapers or stuff like that, right?
Yeah, so this is the compatibility thing is always the problem when we disable old TLS features. Now, if you add more protocol versions, super easy, right? Like nothing's going to break if we add more support. It's when we start chopping the tail off, and that's when we're like chopping this tail end of the web off. Now, SSL version 2 and 3, I'm super comfortable with removing those because if there's something out there that still depends on that, you're literally talking about a device from like the 1990s, and it probably wouldn't work with a lot of other stuff on your website. When we come in towards TLS 1.0, yes, we're coming into the 2000s now when devices introduce that, but again, that's still a very old device. And I guess like my question would be, if it can't do, if it's stuck in the early 2000s, what else can't it do? Like, can it do, new versions of HTML, or can it do JavaScript, or Yes, so there is, there is a very valid kind of support question there, but it's also a wider support question as well. Now, the only other thing to note, if you handle credit card payments on your website, you'll be familiar with a company, an organization called the PCI, the payment card industry, and they set out some strict standards on how you're allowed to send credit card data over the internet. You can't use TLS1 if you want to send credit card data through like a payment form. So again, like we're going to talk about our configuration here, but there are also regulatory or compliance things that you need to consider if they're applicable to you as well. So do bear that in mind. Just going to jump back over here actually before I go back in, because we're pretty much done on that in the background. So I'm going to wait for that scan to finish. And we're going to be going back into our configuration, because that protocol section there, that was just the first kind of part of this process. So actually, I want to just show you this here. Should be done in just a second. Must be everyone on the webinar is going and doing scans and slowing it all down. It's normally about 60 seconds to do this, so that's all good though. Now, we'll leave that going. So as you can see, there's a lot of different configuration parts in the 443 section here, the HTTPS section. We've just configured the SSL protocols one. So that's looking good now. And the next thing that I'm going to talk about is Cipher suites. Now, I hate talking about Cipher suites because they're just these like huge jargon strings of text to any normal person. As you can see here, our protocol support line has gone up, so we are making improvements. But the next one is Cipher suites. So there was our protocols. You can see now TLS 1.0 and above, no SSL2, no SSL3, which is what we were looking for. The next thing is Cipher suites, and there's no easy way to talk about Cipher suites. They're just a big string of jargon to like every normal person in the world. But they are really important because they configure all of the finer details of how a browser will communicate with the server. Now, in all of history, you've had quite literally hundreds of choices. You can see the ones on the screen here are just a selection. That's by no means an exhaustive list in its completeness, but there's a lot of options, and as you can see, most of them are red and orange. And this was one of the catch points for people. He's like, hey, I've got 200 choices, and 10 of them are good, and the other 190 are bad, and I need to know which 10 are the good ones and which 190 to throw away. So there was a huge opportunity for error in terms of configuring Cipher suites. Now, I could write these suites out kind of from the top of my head, but that's not something that I would recommend. And the configuration here on the Mozilla config generator is, as you would expect, this is a super good one. So I'm actually just going to take their configuration rather than typing all of this out. Now, currently, my server is configured to use all ciphers, as you just saw there, but I'm just going to put in that string from the Mozilla configuration generator. I'm just going to save the file. And on Nginx and most of the platforms as well, there's a syntax checker. So I'm just going to run a syntax check on the config, make sure I haven't made any mistakes. It says the syntax is OK. So what I can do now is I'm just going to restart the server to kick those changes. And I'm just going to go kick this scan off again in the background. Now, we've done protocols and Cipher suites there. They're pretty much like two of the biggest components in terms of understanding which protocols and versions to use and which Cipher suites. They're certainly the more complex kind of parts of this process here. So we've actually got those out of the way now. As you can see, there are quite a few other things in this configuration, certainly in the scope of this 1 hour session. We're not going to be covering everything in great depth. But what I do want to do is show the difference that you can make on a grade like on SSL Labs, that you can really strengthen your configuration and go from, we started with HTTP and nothing to a good, well-configured HTTPS website with minimal work. And I appreciate, people have to take this and apply this inside their own organizations and projects and things. But just, the core concepts here of generating the keys, getting the cert, and actually writing the configuration, I think it's more approachable than some people think, I hope, is the goal here. So back onto the scan is finished. You can see that already we've gone up to a grade B on SSL Labs. Our protocol support is good. Our certificate is good. Our Cipher strength is pretty good. I'm really happy with that bar at 90%. That's absolutely fine. The only other thing that we would have to look at here potentially now is the key exchange. The really good thing with SSL Labs is that it comes back here and gives you the information regarding what the problem is. So the server supports weak Diffie-Hellman key exchange parameters, grade capped to B. Now, if we come down here, let me just find the appropriate section. Where are we? DH 1024 bits. Now, I'm going to fix this one as well. I'll just close my notes by accident. That was great. I'm going to fix this one as well because I do want to be able to get us up to that A+ grade on SSL Labs. So dh2048.pem. Helps if I put this window back over here so that everyone can see it. Where is that? I have to reopen my notes. Sorry, I just closed them. That was a great idea. There it is. So I don't memorize all the commands for all the different platforms. I just want to read the manual. So dh param, that was it, dash out, dh-2048.pem 2048. So I'll get this running because that's going to take a second. One of the things that I'm generating here, this is called a Diffie-Hellman parameter, and this is directly related to how a browser and a server connect to each other. And again, for now, you'll just have to trust me that this is the right thing to do. I only have a 1-hour session here. I would love to embellish all day about what Diffie-Hellman and what key exchanges are, but it is a good idea in order to configure these things to be stronger. So I generated this file called dh-2048.pem. Now, if we look in the Mozilla config generator and find the appropriate line here, which is SSL DH param, so you need to set this value here. So I'm just going to grab that one, and we're going to set this in our config as well. So we'll come down to the bottom, drop that in there, and it will be in /etc nginx dh2048.pem. That looks good to me. We'll just do a quick config test. Yeah, I haven't typoed anything, and we'll just restart nginx. And then I'm going to kick the scan. Now, hopefully, that small change will push us up to an A grade. And we'll have gone from an F to an A in quite a small amount of time there. And we'll be using a really strong and really robust TLS configuration. Now, the interesting thing with this is that's actually, in terms of TLS, that's everything that we need to look at and consider there. So whilst that's scanning, I'll just quickly talk you through this again. We went and we got our certificate from Let's Encrypt. So we have a valid certificate from a certificate authority. That is the key that we generated right at the beginning. We told our server which protocols we want to use. So we disabled SSL version 2 and 3 because they're just far too old. TLS version 1 is the absolute minimum you should go to. Arguably, it should be newer than that. The ciphers, again, I borrowed those from the Mozilla config generator. This is a strong selection of ciphers. And then the DH parameter, that's what we've just generated and re-kicked off the scan with. So with just those 5 lines there that we've done, that's all of the TLS configuration that I'm actually going to do. That's a sufficient amount to get us started and get us a reasonably good grade. You can see it's just popped in the background here now, and we've managed to take that up to an A. So we've got rid of that Diffie-Hellman warning, which was here previously. That was our last warning, and it's now done and gone. But I did say that the highest grade that you could get was an A+. Now, there is one thing left to fix, actually, and this was considered optional up until recently, and it's actually nothing to do with our TLS configuration at all. So some questions coming in. I have one more question. I'll pick that one up afterwards because it's about certificates. I'll defer this to the end. I will hang around for Q&A afterwards as well. So there is one more thing to do here, and it's nothing to do with our TLS configuration. And we're actually going to step up to the application layer for this next part because there is a problem that we need to fix here. And the problem is actually, I want to say caused by the browser, and I appreciate that that's maybe a strong word. So let me just bring this kind of screen over here, and I'll show you what I actually mean by that. So
I probably don't want to start some wars with front-end developers.
So yeah, I mean, I'm very cautious about using that word there. But what I'll do is I'll do a very brief demo of what the problem is, and then maybe someone can come up with a better word for me. So if you were to go to kind of any normal person and say, hey, open your browser and go to Twitter, right? Like most people, I think me and hopefully many here will agree that like the average person would open their browser, type in twitter.com and hit enter. I think that's a reasonable assertion to make. So, you know, the user would literally type in something like this into the address bar and then hit enter. Now, what that would do is that would trigger the browser to make a request, and the browser might make a request that looks like this. So the browser would issue this request as a result of the user typing in twitter.com and hitting enter. Now, the problem with this is, and you can kind of see what I'm hinting at here, right? This is a HTTP request. So no, I don't want to open it, Notepad. This is a HTTP request. So you type in twitter.com, out goes the HTTP request. Now, we all kind of know what's coming back, right? It's going to look something like this. And this will be like twitter.com. So that's probably what we would expect to get back from Twitter. And then, of course, the next thing out of the browser would be that GET request that would follow the location header. So this is kind of like the standard process that we would expect to happen when a user tries to navigate to a domain. I think it's fair to say that most people don't type in HTTPS:// I know I don't, so I think that's reasonable. But the problem is this opens up the user for a massive possible attack, because when we're talking HTTP right here at the beginning, we're talking HTTP, which means that if there is an attacker on the network, and remember, we're deploying HTTPS to protect ourselves from an attacker on the network. So we've kind of already acknowledged that attackers on the network exist. The attacker on the network can see this request. They can see the fact that this HTTP request has come out of our browser out to the world. So what the attacker will do is they'll say, you know what, all of this stuff here, scrub all of that. We're not going to let that happen. And we will just do this. And then, you know, like something like they build their own 200 HTML response. Because if your browser issues a HTTP GET request, and then you receive a 200 OK and here's some HTML, why would your browser think there was a problem? And this is what we call an Ssl stripping attack. If you want to go look up the term, and there's tooling and all kinds of stuff that you can read on this, I'll put the name up at the top there. This is what we would call an Ssl stripping attack. It's basically all boils down to this first request here, that most navigations, when you trigger them, are kicked off on HTTP, and we expect a 301 back. But if someone gives us a 200 OK, then our browser's like, OK, I sent a HTTP request, I got a HTTP response, like, this looks good, this worked as intended. So the fact that Twitter supports HTTPS and they have a redirect actually doesn't mean anything at all. So we have to fix this, because this was just going to keep happening. And yes, you know, people come back and say, but, you know, your browser will cache the 301 for a period of time. Absolutely. But at some point, you're going to go back to HTTP in the future and they will get you. So we have a thing. We have a thing to fix this problem. And it's called, I'll go to this one first, HSTS. So I wrote an article about this. If you want to read up more on this, it's called HTTP Strict Transport Security, which is a bit of a really big name. Now, HSTS fixes exactly this problem. It fixes the problem of Ssl stripping. Now, there's actually two choices here for the browser. If you think about it, if the user types in twitter.com, the browser is making the assumption of HTTP. But what it could actually do is this. It could make the assumption of HTTPS, but it doesn't know. Should I do HTTP or should I do HTTPS? Now, we do HTTP because, of course, years and years ago, it was the only choice. And now HTTPS exists. We've just kind of relied on the 301 redirect mechanism. We need to be able to tell the browser, forget HTTP, we are a HTTPS website. And this is what HSTS does. So I'm going to use one of my tools to scan my website. And this tool, security headers, it scans the HTTP response headers of a website. Now, you can go to the tool again, like you just saw. You can type in the domain, you can scan it. The thing that I'm interested in here is the raw headers. Now, these are all the response headers that came back from my website. So, you know, we've got all the ones that you're familiar with, HTTP, date, we've got set cookie. Down here, we've got the server header, all of the things that you would normally expect. But down here, we have this other thing called strict transport security, HSTS, like I just talked about. Now, this is how you turn on HSTS on your website. You just issue a new response header alongside all of your existing response headers. And there's only actually two things that you need to do to set this up. Now, max age, as I said, HSTS tells the browser that we are a HTTPS website and you must talk to us on HTTPS. This is how long the browser must remember and apply that setting for. Now, this is about, that's about 1 year in seconds. Because it's defined in seconds. So you're saying, look, for the next 1 year, every time you come to my website, it must be on HTTPS. Forget this HTTP stuff. We don't do that anymore. Include subdomains is optional. Now, that may be appropriate for you. It may not be. Maybe you've only migrated part of your website or not. So you turn that on and off at your own discretion. The only thing that's required is the max age. So when you come to my website, I say, we only do HTTPS here. And we only do it like for the next 3 million, whatever, 31 million seconds, for the next 1 year. So I want to show this in action. I want to show this kind of working. And as we just saw, my website actually has HSTS on it. So what I'm going to do is I'm going to open the console for my website. I'm going to dock this at the bottom actually so that we can all see. And zoom in a bit to make it a bit bigger for everyone on the call. And what I'm going to do is I'm going to try and go to my website on HTTP. So I'm just going to delete this HTTPS part here. And I'm going to manually type in HTTP scotthelme.co.uk. And I've got the network tab open so we can see what happens. I'm going to hit enter. So if I zip back up to the top, we can see the very first request out of the browser was here. Now, I'll zoom in again. You can see that the request URL was what I typed. It was http://. But the browser got a 300. It was a 307 specifically. And it actually says internal redirect. And the reason was HSTS. Now, what's actually happened here is because my website has HSTS configured, the browser knows that it's not allowed to talk to me on HTTP and that the browser must prevent that from happening. So what the browser's done is the browser has redirected. You can see the new location header here. The browser has redirected to HTTPS. And if we look, the next request out of the browser was indeed that HTTPS request. Now look at the waterfall. Look at the time on that. There's no way that went out to the network. That proves it was an internal redirect. So the browser was about to make a HTTP request and it was like, nope, we're going to pull that back in and we're going to send it on HTTPS instead. And this is how we fix the Ssl stripping problem that I just talked about, because this GET request here, the one that goes to HTTP, we can get rid of that now. And the client will go straight to HTTPS. So that closes this whole kind of loophole, essentially, this method for the attackers to get into our communications. So the last thing that we need to do to get an A+ on SSL Labs is to actually turn this on. And that's the only thing that we're missing. So again, over to the Mozilla configuration generator, you can see here there is an add header directive, strict transport security, max age with a really big number of seconds. So we're just going to grab that. I'm going to come down to the bottom here, and I'm going to add that to my own configuration to turn this on. So add header, strict transport security, big number of seconds. I'm going to save that. I'm just going to check my configuration. I'm sure, is everyone else like me and you press up rather than retype a command? It's like, I might have to press up 100 times, but I'm not going to type a command out. So we've deployed that. I'm going to restart it. And what I want us to do now is go back over to SSL Labs and I'm going to re-kick off that scan. Because HSTS is the thing that is missing to take us from the A to the A+. And as I said, it's nothing actually directly to do with our TLS configuration. It's nothing to do with encryption keys or Cipher suites or protocol versions. It's actually an application layer construct to make sure that the browser knows we demand and expect HTTPS on our website. So what we're going to do is let that scan finish. That will hopefully push us through to the A+. And then I've seen a couple of things pop up on the Slack. I'm going to open it up to the questions on the floor with the last kind of few minutes that we have here. But I am running on time, so I'm really happy with that because I like to do these things very unscripted. But that sometimes means that we can run over. But this will take us up to that A+ now. And I hope that this was informative. I hope that it shows, maybe there are less barriers than some people thought to getting certificates or to actually using HTTPS. I appreciate, everyone will have their own constraints within their organizations, within their own deployments, but I just want to kind of use this to open the door to show I've just done that live and unscripted. Thankfully it all panned out well and nothing broke, but you can see there now I'm up to an A+ on SSL Labs. And there's no real industry standard on encryption. There's a couple of requirements from, compliance like PCI, but there is no official standard. No government says this is the configuration that you must use. SSL Labs is that standard. It's the de facto standard. And I don't know a single person, if you get an A+ on here, that would say you have done something wrong or there is something further that you need to do. So, there's a very short period of time to go from an F and everything was broken. We've gone all the way through to an A+. Go scan your bank or your credit card company, see if they achieve an A+. No, don't do that. Or if you do, don't tell them I told you to do that. But I want to open it up to the floor now. We've got just a few minutes left. I do want to make sure that we have a good Q&A session. I'm keeping my eye on the Slack here. Laurent, is there anything from you at this point?
It's wonderful. I guess maybe I'm just wondering from like all the sessions that you're doing and workshops on HTTPS and that security for that are you seeing more adoption? I mean, probably is, right? Around SSL and like best practices.
Yeah, so for sure. I mean, like there's two parts of your question there. So what I'll do first of all is answer the first part, which is about more adoption. So I run a couple of other projects that I haven't talked about yet. So I run this thing called crawler.ninja, and this is a crawler that scans the top 1 million websites in the world every day. So it goes out, it gets the list of the biggest 1 million websites, and I scan them. And I look at all different kinds of security aspects. It dumps out the raw data. So if you want to come and have a look, you can access all the data here. So, lists of websites whose certificates are expiring imminently. We've just talked about HSTS. So this is the list of websites that had HSTS configured, for example. So there's all different kinds of things in there. And of course, like one of the things that I can track, as you mentioned, is utilization over time. Now, what I do for that is roughly every 6 months, so usually in February and August of each year, I do an analysis of that data to look at what happened. So you can see here from August 2018 to February 2019 what the difference was. And if we look at this bottom one, we can see in August 18, which is about 12 months ago, we went from 51.7% of websites on HTTPS up to 58.4 in just 6 months.
From the
so that's a really big increase. And that's basically what this looks like over time. So back in like January, February, and August 2015, when I started, there was only like 12 or so % of websites redirecting to HTTPS on their homepage. If we fast forward to February this year, we were up over 60% on some of the scans. So that's a huge increase in adoption because these are the biggest 1 million websites in the world. And we're taking these significant steps each time I do this report. So yeah, absolutely. Widespread adoption is on its way. We're not, this line needs to keep going for quite some time yet, but we are certainly making some tremendous progress.
Yeah, this sounds really great.
Let me have a look at the Slack. Does this work the same? Andrew, if you could just clarify that question for me. Do you mean like, will they, I just have to re-clarify that. I don't want to answer the wrong question, that's all.
I'm wondering if maybe HSTS works on mobile browsers, maybe.
Oh, so if it was from slightly a while ago, okay, yeah, so that makes a lot more sense now. And I'll answer that one, and maybe Andrea can tell me if it's a different question she had. The answer with HSTS is it's up to the client. So this is a client-enforced mechanism. You as the website operator set the policy, and then we depend upon the client to respect the policy and enforce it. Now, I use a website called Can I Use whenever people ask me support questions. So if we come here and have a look at HSTS, strict transport security, you can see that in terms of certainly the desktop browsers is great. The mobile browsers is pretty good as well now. Once we step outside of that realm into other clients, it's really up to the discretion of the client to respect the fact that the policy is set. So, certainly for desktop and mobile browsing, it's pretty solid. And, like from the perspective of if the client doesn't support it, yes, the client isn't getting that support, but I guess that just leaves them where they were before. There's no kind of detriment. And that's the thing that I like about a lot of these features is that, yes, you can turn them on. The worst case scenario is nothing changes. The best case scenario is if the client does support it, then the client will give their user extra protection. So, yeah, I mean, the support is good. It's 96.48% of mobile and desktop browsers, as you can see here in the top right. But I'm not sure on, like web views and things like that. I'm not sure what drives them on the Android platform especially, but my guess is that if you're on a recent version of Android, then things like that should be supported. I would certainly hope so.
Yep, that makes sense.
So I'm having a look through the Slack. I don't see any other questions for me right now.
I think just the one from before about including multiple domains. But that kind of maybe.
Oh, okay, yes.
Maybe that just ties back into my kind of last question would be maybe, is there some online guide that you have on your blog that would be able to be a good resource for people to just follow if they need to go through something like this themselves to, set up an SSL and all of that?
I wouldn't say there's one blog. There's there are blogs. Unfortunately, it's not a one blog thing. Certainly, if you have any specific questions, fire a question at me on Twitter. I'm always happy to at least point you to a blog. I have a lot of blogs. It's hard work to kind of skim through them. So, if you have a quick question, I'm always happy to point people towards the correct resource. If you are interested in the kind of thing that we've done today, I appreciate it was very high level, but I do training on TLS, so there's always, the opportunity if you're really interested or need to for your job role, get in touch. But yeah, just shoot me a DM, shoot me an email. I'm always happy to help people and point people in the right direction. But there is one last thing. Do I have an extra minute to cover something? I want to just one
Sure.
extra kind of bonus thing. So
let's do that.
As the owner of a domain, I've just got a certificate for my domain and I had to prove control, and there's a very formal process. Now, with any process and with any organization, there's a possibility for mistakes to happen. Imagine if I'm evil hacker Scott and I'm sat here and I go to a certificate authority and I somehow trick them, or I find a bug in their application and I say, I am PayPal.com. And the certificate authority turns around and says, okay, here is your certificate for PayPal.com. This is what we call a misissuance, and it's a very bad thing to happen. It happens very, very rarely, but it does happen. Obviously, these organizations are made of people just like me, and we make mistakes and things break. So there is a way that you can actually track what is going on in terms of certificate issuance with something called certificate transparency. Now, I have a blog post here, which is an introduction, as you can see. If you're interested in the details, what I'm going to show you now is just the cool stuff that you can do with it. If you're interested in the technical background, go read this post here. But with certificate transparency, all certificates that get issued have to go on a public record, and that public record can be searched. Now, there's a load of different websites that you can use to do this. One in particular that I like is this one called Search. So I'm just going to zoom in a bit for people on the call. And what I can do is I can search, for example, for my domain, and it will show me, this is the list of all of the certificates that have been issued for scotthelme.co.uk. Now, you can see here, this was when the certificate started, so the 26th of August. This is the latest one, who it was issued by. You can click through into the certificate, and you can see here it was issued by Komodo. It was issued something to do with Cloudflare. If we search this page, you will see there is my domain inside this certificate. Now, what I'm hoping is, because obviously there's a small delay here, is I'm going to do the domain that I just searched for. And oops, just got one for it. If I could type, that will help. There we go. Let's have a look. Give that a second because it's quite a big query. But what you can do is you can come here and search for your organization and see hey, we think that we only have 3 certificates right now. And you can come here and do a search. Now, already we can see that there is the demo.clue.net certificate that I got at the beginning of this call. So if we click into this one for the specifics, You can see it was issued by Let's Encrypt to demo.clued.net. This was the time that it was issued at. And then down here should be the www.domain as well. So that's actually the certificate that I applied for just earlier. And it's already here, publicly searchable. Now, this is great for me because I can just confirm what's going on. The idea is that as a person that owns a domain or an organization that owns a domain, you can keep an eye on what's going on. You know, did someone get a certificate that shouldn't have one? Did somebody in my company not follow the correct process? Like whatever it may be. But this is super cool. I often come in here and just poke around and you can search, you know, like, I don't know, bbc.com, whatever it is that you want to search for. So you can go look at other people's certificates. And then the really cool thing with that, if you want to be a pest, is you can search for subdomains using the wildcard operator there. And you can find like cool subdomains on people's websites, but don't be responsible if you do this, okay? But you can see here, like these are all the subdomains, obviously, that this organization must have. So it is actually quite an interesting source of information if digging around is your thing. If search isn't working, try out Census. This is the other one. Go to census.io, search certificates, exactly the same process in the top up there. So those are the two main ones that I use. There are other services, by the way. That's not an exhaustive list, just the ones that I happen to use. And what I'll do is I'll actually I've shown quite a lot of websites there. I'll scrape the list of all of my tabs together and I'll provide them over for them to go underneath the video somewhere. But like I say, I kind of just do these things freeform, so nobody knows where we'll end up.
Yep, those are some good links. As you said before, probably use them responsibly.
Yeah, always be nice.
Yep. All right. Well, we're a bit, I think, on time, so I'm gonna wrap up. That's all we have for you today, people. And thank you for everyone, you know, staying along and walking through this with Helme and with Scott Helme around HTTPS security. If you have any more questions, definitely go ahead and post them on the channel or just shoot them out to Scott's Twitter. You know, just spam his inbox. That's just fine. Happy to do it. Huge thanks to you, Scott, for everything, basically, just for being here and walking us through this. You are definitely one of my HTTPS heroes. Our next session, for everyone staying on, is in 2 weeks, 26th of September. We're going to check out a talk about the state of Kubernetes security with Jimmy Mesta. He's a CDO at Manycode Security. So definitely do sign up if you want to get into that. And thank you, everyone, for just staying along. And thank you, Scott.
Thank you very much.
All right.